Today we are going to learn fundamental theorem on arithmetic. See, the statement is every composite number can be expressed as a product of prime. Prime means prime number, and composite numbers are those numbers which have factors other than 1 and itself. And this prime factorization is unique apart from the order in which the prime factors occur. Now simply we can explain you with the help of an example. If 15 is a number which is actually a composite number, so it can be written as 3 into 5. So this 3 into 5 in this form is called the prime factorization, and this prime factorization is unique, means you cannot find factors of 15 other than 3 and 5, and the factor must be prime also. But yes, of course you can write this 15 also as 5 into 3, but these 3 and 5 which are prime will not change, and you cannot replace them with any other prime number. So the order can be changed, but prime factors will not change. Take another example. Let's say 26. 26 can be written as 2 into 13. So 2 into 13, 2 is a prime number, 13 is a prime number. So this is called the prime factorization. Or you can say 26 equal to 13 into 2. So these are the examples of prime factorizations. Now if I take another example and you will tell me whether it is a prime factors or not. For example, let's take this is also the example, this is also the example. So take another example. I'm taking suppose I'm taking 28 and I'm writing this is 2 into 14. So my question is it a prime factorization? Of course it should not be prime factorization, because 14 is not prime. 2 is prime, it's okay, but 14 is not prime, so it is not called the prime factorization. So the correct answer of this 28 will be, this is wrong, and the correct will be 28 2 into 2 into 7. So you can see that prime, all the factors are prime, the order can be changed. So this is what the prime factorization, and this is the fundamental theorem on arithmetic, that every composite number can be written as product of prime, and this prime factorization is unique. So this theorem is talking about only composite number. If I take 5 which is already a prime number, so we cannot apply this fundamental theorem on arithmetic on prime numbers like such as 2, 3, 5, 7, 11, 13, etc. So now come to the exercise 1.2. The first question is express each number as a product of its prime factors. For example, this is 140, 156, 3825, 5005, 7429. So you have done all these in previous classes also. 140, you may have this method like 140 ko you can write it 142, then this is 72, this is 35, then 5, this is 7, then 7, then last it is 1. So 140 can be written as 2 into 2 into 5 into 7. So this is the prime factorization of 140. Let's take another example of 156. This is 156. 156 you again do like this: 2, 7, 8, 2, 3, 9, then 3, then 13, then 13, and last this is 1. So 156 also can also be written as 2 into 2 into 3 into 13. So this is the prime factorization. So this third part, fourth part, fifth part, you try like this only. Come to question number 2. Find LCM SCF of the following pair and verify that LCM into SCF is the product of two numbers. This is very important result, and many times it has been asked in the exam also. Exam means board exam now. So please take care of this formula very well and use this in these parts. So first part is 26 and 91. So 26, first you make the prime factorization. 26 can be written as 2 into 13, and 91 can be written as this will go from 91. You can see the fact 91, you can see it can be written as 7 into 13. 7 is prime, 13 is prime, so this is the prime factorization. Now this first part is asking to find LCM and SCF of the following pair and verify the result. Now LCM, how you are finding LCM, I don't know, but this time we'll use the prime factorization. So to write SCF, we see only the common factors. So here the common factors, you can write one from your side if you want, otherwise it's okay also. 13 is common in both these two factors, and here also 1 is common. So 13 you can see common, so it can be written 13. 13 is the SCF. For LCM, now you have many ways of finding LCM. There is another way of finding LCM, like you do 26 or 91. So you do like this 13, you do 13 2 ja, 13 7 ja, then this is 2 1 7, then this is 7, this is 1, this is 1. So LCM will be 13 into 7. So this is one of the way that LCM can be found. 13 into 2 into 7, so which is 91 into 2, 182. Now but LCM can be found using the factors also. You can see those factors which are common, you write them once, 13, but which are not common, like 2 is coming, you write 2, 7 is coming here only, you write 7. So common you write only once, and non-common you multiply all. So you will also get the answer 182. So this is, you have found LCM and SCF. Now the relation is, we'll see the relation first is we'll take LHS. LHS is LCM into SCF. So LCM is 182, LCM is 13. So we multiply that, what comes. Now you see LCM into SCF is this is your LCM 182, this is your SCF 13. You do the product, it will be 2366. Now the RHS, product of the numbers. Product of the numbers means the given numbers is 26 and 91. So you do 26 91, you multiply, you will again get 2366. So it means LHS is equal to RHS, hence verified. So this I have done with one example. You can try with other examples also the same way. Now we'll move to, as I was talking about that previous result, that SCF into LCM is equal to product of the numbers is very important. You can see question number 4 is directly using that formula or the concept, that LCM into SCF equal to the product of the numbers. So it can be seen very easily that LCM is already LCM you have to found, so let it be LCM as it is. SCF, you know, LCF is 9 and the numbers are 306 into 657. So LCM will be 306 into 657 divided by 9. So you can do this simplification like this. This is 3 9 3 jar 27, and 3 6 9 4 jar 36, and this is 6 5 7. Do the multiplication and write the answer. Now you do the product, so product will be 22338. So this is the LCM of this question. Normally it is asked for 1 mark, or maybe it can be asked for 2 marks in the board exams. Please take care of this formula and do some more questions basis on this formula. Come to question number 6. This question number 5 has come many times in the board exams, so better you do the same question, do this question here, and one more is given in the example, which is 4n. So same is there, same both are the same questions. See, what the question is asking from us. Check whether 6n can AND with digit 0 for any natural number n. So now just here some basic things that you must know. If any number is coming 0, if in any number 0 is coming, for example 10, so this can be written as 2 into 5. If it is 20, then can be written as 2 into 2 into 5. If it is, for example 100, then it can be written as 2 into 5, 2 into 5. If it is 300, then it can be written as 2 into 3, you can do 2 into 5, 2 into 5. So now here is very important result comes, and that result is, if there is 1 0 at the end, you will get only one pair of 2 and 5. Now you can see this important result. If there are 2 zeros at the end, then we'll get 2 pairs of 2 and 5. There are 3 zeros in this 1000, then there are 3 pairs of 2 and 5. It clearly, it clearly make us understood that if in any number, if there are suppose 2 zeros, then the prime factorization will have 2 and 5, two pair of numbers 2 times. So now you see this question, 6n can be factorized at 2 into 3 and this whole power n, 2n into 3n. You can see there is no factor of 5, so the number cannot end with 0. So this reason is sufficient to mention, and this is generally asked for 1 mark or 2 marks. Now come to question number 6. Explain why 7 into 11 into 13 in 13 plus 13 and 7 into 6, 5 into 4, 3 into 2 into 1 plus 5 are composite numbers. So you see 7 into 11 into 13 plus 13. This 13 you can see these 13 is common, so I have taken common in the bracket. Then 7, 11 and 1 plus 1 will be left. Now you 13 into 77. So 13 into 7 into 11, you can see that given number has been converted into prime factors. So if there are prime factors, then it means that number is a composite number. So the result, we have already studied this in the fundamental theorem on arithmetics. To the second part, this is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. You can see 5 is common, so 5 can be taken out common. So 5, if you take common, it be 7 into 6 into 4 into 3 into 2 into 1 5. You can see 5 as 5 into 1, so this is 1. So this is 5 into 7 to 6, you can multiply 42, 4 into 3 12, 12 to the 24, 24 plus 1. Now further you can see, now you can do the multiplication. 42 into 24 plus 1, this will come 1008 plus 1, so 5 into 1009. So you can see 1009 is a prime number, 5 is a prime number. So given number was written, now is written into product of two primes. So this is the reason why we can say that this given number is a composite number. Now question number 7 you come. There is a problem. You should read this problem and try to find out like what you have to find. Hint I am giving that you have to find LCM, but you must focus why we should find LCM. And now this exercise is complete. We'll do the next exercise.